Hey everyone. All right, so sorry, trying a different screen recording app, but anyway, today we're going to go over a couple more examples from AP Pre-Calculus 2.9, which is all about logarithms. So I have the first one already written down for us, so if you need to pause the video for a second so you can start your notes and write down the problem, you can go ahead and do that. But today, to start us off, we have a petri dish has 34 bacteria that triples each week. We want to write a logarithmic expression that we could use to determine the week in which there are 517 bacteria. So, to start us off with this, we might want to note we're starting with 34 bacteria. We also want to note it's tripling each week. And we want to determine the week in which there are 517 bacteria. So those are kind of all the key numbers that we're going to need in order to do this problem. So going from there, let's start with the fact that there will be B bacteria in A, which is going to be our initial amount. So we want to kind of label things as we go. Bacteria, initial amount. And then we know it's tripling, so it's going to be times 3 to the n power, where n is going to be the number of weeks. Okay, so we're going to take our numbers that we have and we're going to input them here. So we know our initial amount was 34 bacteria to start with. We also know that we want to determine the week in which there are 517 bacteria. So that's where the 517 is going to come in, because that's how many bacteria we want there to be, or I guess theoretically want there to be. The amount that we're curious about, the initial amount was 34, and then we don't know yet how many weeks it's going to take in order to get to 517 bacteria. So we're going to leave that as an n for now. So to start us off, we've got 517 equals 34 times 3 to the n power. So that would be an expression that we could use to determine the week, but it's not yet a logarithmic expression, right? We start off with an exponential, and now we're going to turn this into a logarithmic expression that we can use to determine the amount of weeks. All right, so the first thing that I would do to solve this is divide by 34 on both sides. All right, and I'm just going to leave this as 517 over 34. It's probably some decimal, but we don't really need to know that at the moment, because eventually we're going to end up using a logarithm anyways and end up having to put something into the calculator, because I doubt this is a nice, like, easy, even number of weeks. Okay, so anyhow, now we have 517 over 34 equals, I'm going to leave a little bit of space here, 3 to the n. And the reason I left some space is that now we're going to use a logarithm. For this one, I'm just going to go ahead and log base 3 both sides, because 3 is the base of our exponent, and we want the exponent, or the exponential part, to go away, right? We would like to get n by itself. So I'm going to base 3 log both sides. So log base 3 of 3 means that we are left with just n over here equals log base 3 of 517 over 34. All right, and this would be the exact form of our answer. So if they ever ask, like, you know, if this is a non-calculator question, this is still how you could answer this question. You could just leave your answer as this. This logarithm represents a number. We don't know what number it is without a calculator, but it would work. This would be called our exact answer. Or if you were to type it into your calculator, all right, so if you have a graphing calculator like this one, you can go to Math, that button there, and then you can scroll down until you see something that says log base. That's how you can change the base to be whatever you would like it to be. And then we can type 517 over 34. If you're using Desmos, I think it's even simpler. You can just use some keyboard features to find log with a different base, or you can use their little menu with all the different functions and things like that. So that would also work. But anyways, we get about 2.477. If you're taking the AP test, remember you want to always round to 3 decimal places or more. They don't penalize you for rounding to more, but I'm going to go with 3. So n equals 2.477 weeks would be our rounded or approximate answer. All right, so that would be good enough for that one. So just kind of a quick recap of what we did. We set up our exponential function that we're going to use to find a logarithmic expression. So we have our end number of bacteria equals our initial amount times 3 to the n, because it's tripling each week. So whatever amount it's multiplying by each time, that's how we know what number goes there. And then we input our initial amount and we input our ending number of bacteria that we are looking for. So that's what we ended up with on this step. Divided by 34 on both sides to begin the solving process. Took log base 3 on both sides so that our n can come out of the exponent. And now we've got our exact answer and our rounded answer by typing it into the calculator. All right, so that's one kind of question that we are going to see in our assignment today. Another type of question that we are going to end up looking at, this is our last type of question for today. We're going to be given some different types of logarithmic expressions, and we're going to be asked, is this expression defined or undefined? So, example number 2. Our overarching question here for each of these parts is this expression defined or undefined? In other words, can I do this? If not, why not? And so yeah, there will be an if not, why not kind of component here also. So we're going to have 3 problems, or 3 expressions we're going to look at. We're going to look at log base 2 of -7. We're going to look at log base 3 of 18. And we're going to look at log base 8, or sorry, log base -8 of 64. Now, if you had a calculator, you could type each of these into your calculator and see if it comes out with an answer. If it does, then it's a defined expression that you can do. And if it doesn't, it's not a defined expression that you can do. But we are also asked why, and also you may not have a calculator available for every single question like this. There's remember, a calculator and a non-calculator section on the AP test. And this could very well show up in the non-calculator section, because we want to know, like, do we actually know what's going on in these scenarios? Do we actually know how logarithms operate? So, to start with this first one, what I might do is start by setting it equal to x, because if it's defined, it has to equal something, right? And then I'm going to undo the log part of this by putting a base of 2 in each side. So now we have the expression -7 equals 2 to the x, which might be an easier thing to think about. If I take a positive number to a power, am I ever going to get a negative number? The answer to that is no. 2 to any power, whatever power I make it, is, if I make it a negative power, it's going to be a fraction, right? If I make it a positive power, it's just going to get larger and larger in the positive direction. So, in short, this expression does not have any solutions. So, we would say that this expression is not defined. You can say it's undefined. Because one reason we could give is 2 to the x is never going to equal -7. Or you could also say because you can't actually take the log of a negative number. All right, so that's going to be a reason why that one might be undefined. All right, the second one, part B. Let's take a look. We've got log base 3 of 18. Okay, so far we're not taking the log of a negative number, so that gives us some hope here that this could be a defined expression. Let's go ahead and try that same process. Equals x. Let's see if it makes sense. So we're going to stick a 3 in the base of both sides because it's a log base 3. So we get 18 equals 3 to the x. All right, could 3 to some power equal 18? Yeah, 3 to some power will equal 18. It might not be a nice whole number, right? It's not going to be like 3 squared or 3 to the third power, right? But it's going to be something between 2 and 3 because 3 squared is 9 and 3 to the third is 27. So we know it's going to be something between 2 and 3. So yeah, this one is defined. It's just not a nice even whole number. Not a whole number, but it is defined, which is good. All right, next one, log base negative 8 of 64. All right, this one we're just going to say, to start off with, logs don't get negative bases. This one is not defined. Can't have a negative base for a log. All right, so there we have it. Yeah, all right. So the things to look for that might make things undefined would be negative bases and then logs of negative numbers. Otherwise, it should be defined. So anyhow, that's all we've got in our new notes today. So yeah, we're going to keep continuing with logarithms pretty much throughout the rest of Unit 2 to kind of wrap up Unit 2 here. So we've had exponentials, now we've got logarithms, and yeah, hopefully this was helpful. A couple more examples of logarithmic functions. Have a good one.